Okay, now that we've done just a little brief algebra review on rational functions, let's talk about where this goes next. And to do this, I want to recall the function that we graphed earlier. Let's recall f of x equal to x squared minus 6x plus 8 all over x minus 2. And when we factored the numerator and then divided out a common factor, we figured out that this graph, this function graphed like the function x minus 4, except we had to exclude 2 from the domain because it set the denominator equal to 0. And so what we ended up with was we had an intercept of -4, a slope of +1, but when we went up 1 over 1 to get to 2, that's where we had to place the hole in our graph, and then we could go up 1 over 1, and we could then graph our linear function right there. There's our function f of x. It behaved like a linear function x minus 4, except we had this hole right here at x equals 2. And I said earlier in that video, that's going to be the part that we really want to focus on in calculus. So let's talk about why that hole exists. The hole exists at x equals 2 because that value makes the denominator equal 0. And we can clearly see that here from f of x. But if you'll recall that function, when we factored out the numerator, the x minus 2's were actually able to divide out, and what we were left with was just the linear function x minus 4, but we still couldn't graph this hole at x equals 2. So we did something very intuitively as we were graphing it, and I really want you to kind of key in on what you already knew, because if you can understand that, it's going to make this first topic of calculus easier to digest, because you'll understand why it is that we're going to be making some of the claims and the statements that we'll be making. So the question that I have for you is, why is the hole at the point 2, -2? And that may seem like a very odd question for me to be asking. The only thing that we knew about at x equals 2 is that the function is undefined there. But we very specifically put this hole at a very particular point, and we did it for a reason. So, we could have just done like an asymptote, we could have done all kinds of things, but we knew that there was going to be a hole there, and we knew where we were going to graph the hole. When we were doing this particular function, we were kind of counting the slope and said, okay, that's where my hole is going to be. But we knew intuitively where the hole was in this graph, that the hole really is at the point 2, -2. And what we're going to learn is that in the first topic of calculus, it's going to allow us not to say, hey, at x equals 2, it's really equaling -2, because it's not. At x equals 2, this function is undefined. But the first topic of calculus will allow us to describe the idea that as x was getting close to 2. So in other words, when I started here, I graphed my intercept at -4 because that's what I knew to do for a linear function, and then I started going up 1 over 1, up 1 over 1, and that's where I knew my hole was, and then I kept going, up 1 over 1, up 1 over 1. Well, as x was getting closer to 2, and again, for a linear function, I was kind of following its slope, but we knew as x was getting close to 2, f of x was getting close to the value -2. And that's why our hole is where it is. And that's actually going to be a very important topic for us as we start talking about this idea of a limit, which is really the first main idea that we learn in calculus. So understand why you put the hole specifically where you did, and it'll help you understand in the future when we start using this concept of a limit to describe the behavior of a particular function.